All right, thanks everyone for being here. I know that there's a lot of sessions happening in parallel, so I appreciate you staying here with me. My name is Rami. I'm a senior software application engineer. I work in Intel's Data Center Management Solutions group. And my job is to basically work with customers and partners and help them better manage their, their data centers on-premise or in the cloud or in a hybrid environment and make the most out of their hardware. And we do that by a solution that we've developed in our group called Data Center Manager. And it's basically, as I'll show you right now, it's not a typical DCIM solution, but it's not also a typical OEM server management solution either. It's a combination of both that has a lot of benefits that I'll talk about today. So question is, who from the audience still has a data center that they need to manage on a day-to-day basis? Okay, great. Okay, so we're going to talk very quickly about, obviously, I'll skim through the first topic. That's the need for on-demand visibility in today's world, on why you need to manage and monitor your data centers on a more granular level. Then we'll talk about the Intel Data Center Manager. I'll give you a higher level overview of what that is, how it works, and we'll talk about some of its features and capabilities and functionalities that differentiates it from other similar products. And then I can show you a couple of use cases. And if Wi-Fi helps me out, I can also show you a demo. Okay? So that's pretty much the agenda. Like I said, whether you have your data center on-premise or in the public cloud or in a hybrid environment, you still need to be able to manage and monitor and understand how your systems are behaving on a regular basis. And one statistic I shared earlier in the morning that might be worth sharing here today is that over 50% of today's data was created in the last 2 years, and only 2% of that has been analyzed for its purpose. So it's a staggering amount of data that we have here, and that's driving the compute needs of the industry, and therefore the need to manage it is much higher. Okay, so another quick intro slide here is that we believe at Intel in 6 pillars for a successful data center management solution. One is being able to provide real-time power, health, and thermal data. Being cross-platform being cross-platform, meaning that it's not tied to a specific vendor or a specific type of device or a generation. And that's also tied here to broad device coverage, as you'll see in a few minutes. DCM supports not only servers from Intel, but also other devices that you'll find in a typical data center, including PDUs, SANs, NASs, and we're adding constantly to that list. Like I said earlier in the morning, we're working right now with some of the major liquid cooling providers to be able to add monitoring capabilities for those systems within DCM as a solution. Okay? All right, so without further ado, what the heck is DCM, right? So it's a solution that resides in your data center, whether on a physical system or a virtual machine or a container, as long as it has network access to the devices that you want to monitor, right? So, as a solution, it uses all the different hardware protocols, whether it's all the instantiations or variations of IPMI, Redfish now, of course, as well as SNMP and some of the other protocols for managing mostly networking devices. So it uses all of those different types of protocols to be able to control and manage and monitor rack servers, blade servers, UPSs, SANs, NASs, etc. And one thing to notice here is that while this is a web-based or API-based solution, there's 2 ways to actually manage it or use it. One is through a management console, a web-based management console that is meant to the average user, right? So someone who just wants to manage their data center. But we also provide an SDK that gives you programmatic access to the same APIs that the web console is based on. And that is helpful for partners that we work with, like Schneider Electric, NetZoom, graphical networks, etc. They use our SDK to be able to provide their own management solution that might be a little bit more in-depth than what DCM provides in terms of network and cable management and so forth, right? And ticketing systems and all that. Yeah, so the whole idea of DCM is to basically reduce your total cost of ownership by improving, asset management, being able to increase your data center reliability. There's ways to control what those servers do when you have a power failure. There's something called emergency power reduction that is built into the hardware that we take advantage of. And then we talked earlier today about cooling and thermal granularity, thermal analysis and cooling efficiency. So there's a lot to talk about here. And basically increasing or maximizing your compute density. Like I said in the morning, of course, the more servers we sell, the better, of course. But we want to be part of the solution and help or work with the industry to not have to just exponentially grow when you don't really need to. So there's a lot that we do on this side in terms of increasing rack densities and so on, so forth. Okay. So there are three types. I touched on this already, but there are three types of partners we work with. There's the OEMs, like I talked about, and all of the solutions that they offer are mostly based on DCM's core capabilities in terms of health monitoring and power management and setting power policies and doing all sorts of controls. So whether you're using Xclarity from Lenovo or OMPC from Dell or Supermicro Power Manager, they all have the same capabilities. They obviously add more features that are more specific to their brands or their servers. But we work with them very closely, and we don't really compete in that, in the way that people might think. We actually partner with them very well. So that's, of course, one kind of customer or one level of partnership that we have with the industry. We touched on this as well. So we work with all these different kinds of resellers. They all have different software solutions that tackle things or focus on specific areas, like I said, cable management or entire building infrastructure management like Schneider or Siemens, etc. And all of them have a data center management component, and they use our APIs and SDKs, like I mentioned before. And then there's obviously the direct customers, anyone with a data center who just needs better management and better insights into how their systems are performing. Okay, so a little bit about what differentiates DCM from other solutions. Like I said, the ability to automate health monitoring, so to be able to set thresholds and tell it, I care about certain events, and sends you emails when those events happen at a much frequent level than you possibly can with other solutions. And then being able to improve your system manageability. I won't go through the whole list, but I'll highlight some of the most important ones. One thing is identifying underutilized servers. This is always a problem in data center environments. I think one of the key statistics here to remember is there's almost always a 15 to 20% of your data center that's underutilized. So you're able to quickly identify those with DCM and decide whether you should shut them down or migrate them into, consolidate systems into virtual machines or, end of life them accordingly. Another thing is being able to increase workload rack densities, right? So not just adding systems, but figuring out, not depending on your derated power, but using the historical data that DCM collected over time to be able to understand the actual utilization or power consumption of these devices over time, and therefore rack and stack accordingly, right? I'll talk about that also. And then one thing is being able to provide this granular thermal kind of level of your data center. So some people visualize it as considering each server as a wireless temperature sensor, so to speak. So instead of depending on a sensor that's on one side of the room, right, the temperature sensor on one side of the room, you actually can see the entire thermal map of your data center in that level. Okay, any questions? Okay, one thing that I wanted to refer to on this slide is that one DCM instance can actually manage up to 10, I think the actual number is 20,000 IPMI-based servers today. So, and even if you're a big organization that needs more than that, you can actually, there's a way to concatenate or DCM instances and have still a single viewpoint of your entire infrastructure.
You mentioned these servers have, because they have probably their own temperature sensors on it, right?
Yeah.
Do they communicate today in, like, on a wireless? Do they?
Sorry, communicate what?
Are they communicating on wireless today?
No, so everything is all this telemetry, so power, thermal, health, and use CPU utilization, right? All that is exposed via the BMC, the base board management controller, and you need to basically hook it up to the network, right? So the best thing about this entire solution is the fact that it's agentless. You don't have to have an OS running. You don't have to install anything. There's nothing that's going to impact your performance or workload or anything like that. You're just extracting the data that's already there, right? There's zero interference. There's a separate embedded processor that's running the BMC, so there's literally zero impact to the actual CPU running your workloads. Okay, so yeah, some additional features. A couple of slides, and I'll show you a demo. Right? So additional features that are a little bit more focused on data center or on servers, right? So the ability to look at all the subcomponents of a typical server and see their status right now. So whether it's the CPU, memory, fan, storage, battery, etc., you get to see their current status as well as their recent fault history. So you get to see when each of these components actually failed over, in the recent history. And then there's one interesting thing here that I think we're one of the few companies that provide this, is being able to identify firmware version outliers. Every data center has a variety of servers. Sometimes the same model just purchased at different points in time would end up with two different firmware versions. And that could impact performance, reliability, security, whatnot, right? So being without anything, without having to do anything, DCM would be able to identify outliers. So for example, most of my servers in this rack here are on firmware version 2.54. There's a couple that are running older ones, a couple of running newer ones. So with this information, you'll be able to make decisions like maybe I should upgrade them all, maybe I should downgrade some, and sometimes that happens, you need to downgrade. But you can make decisions such as those. And then you obviously get the ability to remotely connect to those systems via the KVM, the remote KVM. So that gives you access to the system as if you were physically there. So if you have to manage a system that's thousands of miles away, you can actually do it remotely. And you can even, again, you don't have to have an OS running. You don't need, VNC or any other protocols, right? You're communicating out of band, and you can even load virtual storage, so an ISO file, and install an OS all remotely. Right. And then this is a feature that's currently only for Intel data center blocks, as they're called. They're Intel white box servers, where you have the ability to do firmware updates with a click of a button to not just one system, but thousands of systems at the same time. So this has been the most requested feature. Unfortunately, it's very hard to implement this for all OEMs. Every single OEM has their own firmware variation and complications with security and certificates and all that. So it's right now a feature for Intel white box systems. Yeah, and you can set those up to run at a specific time to minimize downtime. Right? So you can say, I want to run this firmware update for these servers at this time. Okay, so talking a little bit about identifying underutilized servers without really having to do anything. Remember the strengths of DCM, even though it just collects, 4 kind of parameters, it's what it does with that data. So a lot of analytics and lots of reportings come into play here. One of the most important ones is being able to identify very quickly which servers are not actually doing a lot of work. So hands up if anyone had that problem. You're looking for space. You don't know which servers are actually being used. You don't want to take someone's server down. You're going to get a call next morning with someone screaming at you. So this is one of the most requested features as well. Okay, and then this is probably another one, which is I touched on this already before, being able to increase your rack densities by not depending on the derated power of those servers. Most servers are rated at 400 watts, which typically means maybe 16 nodes per rack. And if you do that, but your systems only consume 200 watts during the entire year, then you could potentially add 20 to 25% more servers in that rack, and then you don't have to worry about, okay, where should my next servers go? I need more space, find a new spot, blah, blah, blah. So here's a proof of, I'll skip to this actually. So of course it's a great idea to depend on the historical power consumption of those servers, right? But what if the case happens where those systems actually do get utilized? You don't want to blow up your rack or your server room. So what we end up doing is usually combine both, which is being able to use the historical data with setting power policies or doing a power cap on the rack level, right? So you tell the rack, you usually have 8 kilowatts approximately. So you tell the rack, you tell the rack not to exceed that limit, right? And then what DCM does is that it throttles the CPU's frequency down a little bit so that it stays within that limit. And then what I was going to show you here is the POC that we did recently, where we did exactly that. We tried to increase the rack density from 16 nodes to 22. And we did that by simulating a maximum power budget for the rack, which was 6.2 kilowatts instead of 8.6. And what DCM did is that it started fluctuating the CPU frequency a little bit for that workload to maintain that limit, as I said. But DCM's job is not to evenly distribute the budget, right? Its job is to stay within those limits. So in this case, you see that some servers benefited more. Their CPU ran at higher frequencies and had more work done, while others suffered accordingly. So that sometimes is not really acceptable, depends on your workload. So what we ended up doing is combining that with another power policy that we set, which was the minimum power budget, setting that on each node. We told DCM that while your rack should not exceed 6.25 kilowatts, don't let any node go below 300 watts. And that evened things out much more nicely. So this is a real-world example that customers have benefited from massively. And then we do, obviously, this is for a POC, for a certain rack, for a number of servers, but then you extrapolate the ROI from that and multiply that by thousands of servers. The amount of savings is very easy to justify to management. Any questions so far? Okay.
Another question?
Yeah.
Can you actually see implemented, like this is interesting that you can do what you can do in a single data center, right?
Yeah.
But let's say the multiple data centers, and now you have thousands of these servers all over the world, right?
Yeah.
Is this something that you have implemented to learn from all of this, like a huge infrastructure?
I didn't get your question. Can you repeat?
Multiple data centers,
Uh-huh.
multiple facilities. So
Yes.
you have the same model in 20,000 other places. So can you learn the behavior, predict the behavior of that particular server?
It's hard because it depends on the workloads that those servers are running, right? If they're running the exact same things, then yeah, you can start to create prediction models accordingly. But usually they're not. Yeah. So we haven't had customers ask for something like that right now. Okay, so I'm gonna, this is one last marketing kind of slide. Then I'll try to use show a demo, but if it doesn't, I have some screenshots. That's gonna be the next best thing. So talking about predictive detection of cooling anomalies. So we talked about this upstairs. in the lab. So using each server as kind of a sensor, you can have a much more granular kind of understanding of the thermal footprint of your data center, right? And there's a way within DCM to visually illustrate that so that it's easy to detect anomalies. And you can also set policies to when such an anomaly happens, what action to take accordingly. Okay. So let me try to switch here to my browser and see if I can show you some of this stuff live. Okay, and I'm going to zoom in a little bit, hoping that it helps. So this is a live DCM instance that we have that I'm, oops, that might be too big. I know this is a little bit too big, but just for people at the back. Right, so this is the live DCM instance that we have, and assuming that you've set up DCM so that it manages servers and you've added some servers, or devices, I should say devices, because again, remember DCM can monitor PDUs and racks and all sorts of different IT devices. You're going to be presented with the dashboard here. And the dashboard shows you a summary of your environment, and it kind of gets you going with your day-to-day management activities, right? So you get to see a summary of all the devices that you have, how many of those systems were connected or got disconnected in the recent past, and you can define that in the settings. You can also see the current health summary of all the devices that you have, and what of those components have had failures. Right? You can also very quickly identify how you're doing in terms of space and power capacity. Let me see if I can scroll down here. Probably not. I'll scroll down here. And then you get to see things like temperature trends for the entire data center. So this is aggregated for all the systems and all the racks and PDUs that you have. How the temperature is doing throughout a month. You can customize that from an hour all the way up to a year. And I get asked this question a lot. I was asked this like maybe 3 times in the booth. The data that's stored is not that large. So a year worth of data for 20,000 servers is going to be approximately 200, 300 gigabytes. So it's a lot, of course, but it's not in the order of terabytes, as people might imagine. Right? And then you get to see here like cooling anomalies, or the highest 3 temperatures recorded in any room. And you can customize those as well. Links to any devices that were deemed unhealthy, and a brief description of what exactly caused it to be unhealthy. These are the results of the IPMI calls. And then you get to see here all the different types of events that happened. You can customize those as well. And I think for most of you here, the most interesting thing would be the power data summary. So these are the most power-consuming devices in your environment, okay? And if you've had any hotspots, these are the most, the hottest servers, basically. And this is the gadget for the firmware outliers and any cooling anomalies. So these are sudden and unexpected temperature drops or rises in a certain room, and you'd have to acknowledge that, basically. Okay, so this is the dashboard. So let me show you a typical use case. So if you decide, okay, this might be worth looking into. Actually, let me start from a system. Let's look at the power consumption. This is my most power-consuming server, right? So if I click on that, I'm teleported into the hierarchy view, and this shows you the physical hierarchy of your data center. I'm going to have to zoom out so I can see a little bit. Okay, so as you see here, I'm actually looking at one device in one rack in one row across and one of my data centers. Okay, and for that server, I see its actual real-time power consumption, 385 watts, and its temperature, as well as its space, which I've defined when I added the system. And then I got to see its asset tag, its model details, And that's the link to the management console that allows me to launch the KVM and virtually connect to that system. And you get to see the firmware details and the fan details, and you can obviously see, like I said, the current health of all the subcomponents, as well as its fault history. And you get to see the temperature and power data for that particular server over a period of time. And you can export that data into an Excel sheet or a CSV file and then consume that in any form. But remember, this is the console, which is the UI. Think of this as a reference UI that was built to showcase DCM's capabilities that just became its own product in the end. Everything that you see here, you can do programmatically. That's what I'm trying to say. Okay, and then, so for some servers, for some HP servers, you don't see the CPU utilization, but for other types of servers, you can. That would be another graph showing here at the bottom. Okay, and then you get to see a visual representation of where that server resides in the rack, and that's usually color-coded to indicate either its power consumption or its health, and you can change that. You can customize that. And then what might be interesting here is to show you the layout. So if I click on the layout tab and I want to look at the room details, so let me choose room 1 because it's a little bit bigger, you see a bird's eye view of that room. Okay? And you can again change the color coding to show you the average inlet temperature. Oops, wrong button here. So for example, if that's not the case right now, but if I had a bunch of racks here that are a little bit hotter than the rest, then you'd know just by one click that you have an airflow problem, right? And then you can click also, if you go to the row level, you can see that front view of that row. There you go. And again, with the visual illustration helps with things like, okay, where are my next servers going to go? Right? Sorry. I keep clicking the wrong button. Here we go. Obviously, no server is this, no data center is this clean, but it's good to see that it could be. Okay, any questions so far? I know I'm going a little bit fast for the interest of time, but I'm happy to answer questions if you want.
Does this integrate with existing DSIM tools? Like,
yes.
There could be different disciplines, different components.
Yes, absolutely. So whether you use DCM as a standalone project or use any of the DCIM solutions that we partner with, you're probably going to be using our technology anyway. Right? But existing solutions, we do integrate with them. For example, ServiceNow and Device42, we work with them pretty well. So they're more focused on ticketing. Yeah. Like if you want to create a ticket to move a server or an entire rack from one building to the other, the Device42's solution would hook into DCM and then tell it that it would automatically move an entire row to a different room or so on. So you didn't have to do anything. Was that what you were looking for?
Yes,
yeah.
Because like some of this stuff is multiple groups, right?
Yes.
Like,
yeah.
The facilities guys want to know the heat and
correct.
power, but don't
correct.
care about how to get to the server.
Yeah. Yeah.
So can things be locked down?
Yeah, exactly. So yeah, so that's why we worked a lot with ServiceNow and Device42, and there's a couple of other ones that I might not be recalling right now, but yeah, we're pretty open in working with anyone. That's for the greater good, so to speak. Okay, so a little bit more on. Let's talk about reliability. Okay, so here you would see a list of all your unhealthy devices, along with all the subcomponents that have failed. And of course, DCM can't really help you figure out solve the problem, but it can help you pinpoint the system easily. And again, integrating with ticketing systems, you can actually, say, click on this system, and then, say, issue a service request to fix the problem. Right? Okay, so some more, well, I get asked this question a lot. So predictive failures. In this version of DCM, we only have predictive fan failures. So if, in the simplest form, if DCM realizes or recognizes that a fan for one of the CPUs has been slowing down over time and the temperature of that server has been increasing over time, then it will probably flag that server fan as a potential threat, and it would flag it so you would replace it. That's the simplest form, but we're also adding, right now we currently have in DCM 3.5, which is just launching right now, the ability to predict PDU fan failure, PDU failures, and also, what's the word? I can't, so storage failures as well, right? And if you have SSDs on that server, you can actually see the details of those SSDs, but this is the only in-band capability that we have right now. So you'd have to give DCM the credentials for the server, and it would need a certain, it works only on Linux right now with a service that you have to install to be able to get this information. Next year, with our next generation of platforms, the need for any agent goes away. All this information will be retrieved out of band. That's one of the reasons why I was telling everyone you have to stay on top, unfortunately, of the technology, because something like this would change drastically. And of course, with SSDs, they're much faster, but unfortunately, sometimes less reliable. So if, an issue with an SSD is more fatal, so to speak. And then with any, it would list the estimated lifespan of those SSD in terms of how many reads and writes are left, and so on. Okay, and then let me very quickly show you the energy tab here. So let me actually go to the dashboard here, and then let's take a typical use case. So, okay, I care about this 28 degrees Celsius room, right? So let me click on that. It will, again, teleport you to the cooling analysis tab, and it will show you a graph or a report like this that would basically illustrate, the temperatures of all the systems in that room. And while it was reported as the highest temperature room, we're actually seeing that most of the servers are running cold. Only a few of them are running hot. So with one graph, you can make deductions like, okay, maybe these guys have component health issues. So I'd correlate that with the information that I see about the system health and see if that's the case. Or I can correlate that with the layout that I just showed you and see if it's an airflow problem. Or you just might have an uneven distribution of your workload. So a lot of customers we work with, programmatically use the CPU or the power consumption to be able to do dynamic workload distribution accordingly. So it's all this by just looking at one graph for 3 seconds, literally. Okay, and this is the tab that I showed you about identifying underutilized servers. So you get to see, how these servers were performing over time. I think this is defined per week right now, but you can customize that as well. And this is the section here where you can define power policies like I showed you, whether it's on the rack level or minimum power policies, etc. Okay, there's a lot more features. Obviously, I can go into depth, but I don't know how we're doing in terms of time. Do you know how we're doing in terms of time?
I'm not too sure. Everything's running behind.
I know.
You have more time.
Really? Okay, all right.
I think somebody will come kick us out.
Okay, so it's good that we didn't need to use any screenshots. But I'm pretty much done. What I just wanted to share is that there's a ton of companies that we work with. I lost my mouse. Yeah, so there's a ton of companies that we work with, and we've kind of divided them by use case, right? So the companies that we've worked with focusing on power monitoring or increasing rack densities or identifying ghost servers or thermal problems, etc. All of these link to white papers that we've released online, showing the PUE and the ROI from using DCM. So if you care about that, one of the recent ones is working with CERN. That was an excellent collaboration between both organizations. I highly recommend you read that, especially for McMaster. So hopefully we can do something like that as well. And of course, we use this internally as well. So Intel IT, we eat our own dog food. So Intel IT has been using DCM quite a bit. Fortunately or unfortunately, I work with them. I have to help them out on a regular basis, but they're a great source of feedback, and they help us define what they need for future features. So like I said, next release, we should be supporting liquid cooling systems, whether it's traditional liquid cooling or even immersive cooling solutions. What else? We're also adding capabilities to be able to do SSD firmware updates remotely as well. That's always a problem, right, with SSDs, being able to update their firmware remotely. And there's a ton of things that we're working on. I don't know if you guys know, but Intel is working on a discrete graphics card for deep and machine learning. It's expected to launch next year. So with its first launch, we'll be supporting that to be able to manage and monitor those cards and their workloads and do the same kind of thing that we do, so that you can manage their workloads and monitor their utilization as well. Sorry, I'm losing my voice here. Yeah, I think that was it for me. Feel free to ping me after this. Grab my card. I'm happy to talk to you. We have a booth. We can go into details into the demo. I can talk a little bit more about some of the use cases in more detail. Yeah, that's it. Any questions?
I have a comment.
Yeah, sure.
Not really a question. When you said you find the lowest utilization server,
Yeah.
and there are a couple of options to do with it. There was a calculation that you had amount of energy savings you get if you shut off the server.
Yeah.
So, as I said, just a comment.
Yeah, sure.
We have done some studies,
Mhm.
and our studies have shown that this is actually a good idea.
Really?
I
Okay.
know it's a common, even in the research, common perception that server constellation is good, but we have found that when you turn off the server, you turn off the fan, and now it's not sucking air. So heat recirculates from the back
Hot air
to the
from
front.
back.
What does it do is that it heats up the front. So what happens is that your cooling unit starts seeing temperature going up, starts working
Got it.
harder.
Yeah.
So you start spending more
I-
power consumption. From a cooling point,
Yeah.
you're saving on the server point
Yes.
part,
Yes.
but you're spending more on the cooling part.
Yes.
And then
That's a
that-
good point, actually.
Actually,
It depends also on the location of where is the
Yeah.
server,
Yeah.
how many servers.
Yeah.
So,
That's a
just
good-
a comment.
That's a good point.
Don't
I actually.
recommending that.
No. When I said shutting down the server, I also meant taking it out completely.
Yeah, I know you said a couple of options just because
Yeah.
I saw the equation
Yeah,
with
what- no,
25% energy saving.
Absolutely.
And I know from research that this is common perception that shutting down servers is good.
Correct.
But I just said from
then
the
follow it up by
experience.
putting blanking panels.
Exactly.
I understand. Yes. Yeah.
Yeah,
So
actually that was something we were thinking of. What can we change in a server when you shut it off? It would lock the fan, so that's the spaces
Yeah.
that the fan creates,
Yeah.
so heat cannot recirculate.
Absolutely.
So
But
that's
if you take that server out, that problem goes away.
if you take it out, and
Yes.
put
So
a lighting pan
yeah,
on
I should have been more accurate and said shut
Yeah.
it down and take it out.
Yeah, no, you already said that. You
I
said
did?
You can
Okay.
take it
Yeah,
out,
but
take
shutting it down
but
only,
yeah.
you're absolutely right. It causes more
And I'm
problems
not
because
sure
it's still
if,
pulling power.
It's also a part of OEM, like where they can give a mode where just fans are on at a very low speed, very low
Maybe.
speed, but everything else is off.
Yeah, I understand.
So that's, but
Correct.
I don't know off the top of my head.
Yeah,
if
because
there are
remember-
HP they provide
Yeah.
any
No,
mode.
you're absolutely right. You're absolutely right. Remember that embedded controller that I was telling you about? That's got to run off of the power. It's whether the system is on or not.
Exactly.
That's consuming power, and that's causing heat, and I completely agree with you.
So the other thing that I'm expecting you guys are working on, you also mentioned, is that when you have some of the servers hot, you go back and look at the layout, or you go back and look at the other graphs.
Yeah,
So the next step would be you shouldn't do that. The algorithm will be doing that
Correct.
for you
Yes.
and just telling you this is what I expect.
yes, yeah, we're working on that, but I can't really talk about that, unfortunately. I was told specifically to stick to the topics. But yeah, good point. We are definitely working on
Yeah,
it.
just a lot.
DCM is a 10-year-old product, by the way. Yeah, not a lot of people, like I mentioned in the morning, not a lot of people think of Intel as a software company. This product has existed for 10 years. We have a ton of partners, so obviously it's a well-known product. but still, lots of people in the industry, every event we go to, people have never heard of solutions from Intel. And if they did hear about software from Intel, it's probably compilers or analyzers or performance libraries, right? So we're one of the few solutions within Intel that we sell as a full product, right? And in two different ways, the console and the SDK as well. Cool. All right. Thank you very much, guys. Appreciate it.